Next talk is Maciej Swiderski from Poland, from Krakow. He works at Red Hat in the business process management area, and he will be talking about knowledge-driven microservices.
All right. Welcome, and thank you for joining us. Today we will start discussing a bit about knowledge-driven services, microservices, up to you how you wanted to call it. But the whole point is that we focus on the knowledge, the business knowledge behind our system, services, and overall system that we will design. So actually, let's start very quickly at what the knowledge is and try to address the lack of knowledge in majority of the systems, where we usually focus on like a system architecture or design, modularity, UI, test quality, code quality, test cases, and so on and so forth. But the main question here is, where is the actual business knowledge in it? Do we actually spend enough time to think why we design the systems, why we implement the system, that and not the other way? So having this in mind actually allows us to build a system that are actually closer to the actual requirements. Because IT and in general software engineering is to provide the value to the business, not just to build software, because software itself is it's pretty much useless. It must serve for a certain purpose. So then looking at the business knowledge that we can actually collect and should gather is actually first and foremost is the data model. The data model, regardless of its structure or regardless of its format, is it Java, objects, .NET, C#, JSON, XML, whatever. The most important is that we capture the knowledge that the data model will carry. So once we have the so-called what, because the data is the actual most important building blocks of our systems, we can start thinking about, but what to do with that data. We have the data, we can send information across different systems, across different parties, different countries, and so on and so forth, but what to do with it and how to do it. In most of the domains that you can think of, you will find business rules. Business rules that actually drive the data that you're going to operate on. There is not a single domain that is just rule-less, so to say. You have certain things that actually address how you can access data, what you can do with that data, and what the data can actually produce when you start transforming this. And this is the why. Next, we have certain operations that can take place on that data. And it could be a structure, it could be unstructured. But anyway, you have something that is a sort of a process that invoking a certain order, invoking certain types of activities within that process will lead to a certain result, the business goal at the end. And this is the how. So it's like, what, why, and how. Three really important topics that you need to think when you start designing your systems or start building and enhancing your systems. And again, regardless of the technology behind it, is it XML, is it JSON for your data model, is it Drools language or jBPM 2 for processes, that's not relevant at the time when you're actually collecting and gathering the knowledge. Once you have that, you can be on a completely different level when you discuss that with business people, which are your customers, which are users of your systems. So when you can discuss that at the level of the business people, you already achieved a huge success. You don't have to have this transformation layer from being the business person into the IT programmer. Then you kind of releasing yourself from having these roles-based assignments like analyst, business analyst, system analyst, developer, tester, and so on. You can start talking to your business people directly. So that was a very quick run through the focus on knowledge while you're actually building your system. But then the tools that I'm going to talk about today, Vert.x, Hazelcast, Drools, and jBPM, are just the tools. You can replace them. You can use different tools for it. The whole point to show it on today's demo is that this kind of technology allows you to build a very quickly, very self-contained software, as a microservice, as a service, that brings the value for your business. So you don't have to think about the technology too much, because the whole point for technology is to support your business. business, once it's defined, the data model, the processes, the rules, can then be combined into a running system. Vert.x is, from the web page, a lightweight, high-performance application platform for the JVM, designed for modern mobile, web, and enterprise application. In general, this is one of the funny parts of working with Vert.x is that it's so flexible and so easy to use. First of all, it's polyglot, so you can pick the language you like, and even more important, you can pick the language that is right for the job. If you have something that is very client-oriented, you can use JavaScript. If you like doing a very back-end stuff with Java, fine, do it. If you have a bunch of code that is already written in Java and you want to reuse that, you can run that so-called vertical, which is the package of code that Vert.x executes. You can just bundle that into a module and run it as a Vert.x module. You can use Groovy, you can use Scala and Ceylon and so on and so forth. All the languages that Vert.x supports, and that's actually growing as well. So you can take advantage of it. That's a polyglot. So you are not locked into only with one language, and you cannot change that. The simplicity. One of the nice things is that many people are actually moving now into asynchronous API. With Vert.x, you don't have to think much. Everything is asynchronous there. So you already have it. So you just start using it. Scalability. That's a nice thing that I will try at least to show on the demo as well. That you can scale individually and very easy by just changing one parameter and starting more instances of the Vert.x module. Concurrency, by default, everything is single-threaded. So there is a single thread operating on your vertical. If you need more, then you just start more instances. But again, they are single-threaded. So you don't have any concurrency issue in your vertical unless you start using shared data, which Vert.x allows as well. Hazelcast, an in-memory data grid. And this is extremely easy to use in Vert.x for your distributed event bus or clustered event bus. Vert.x itself is communicating between the verticals over message passing, so just sending data over the event bus. And once we have that clustered, then our services, our Vert.x instances can communicate pretty much without any knowledge where the other service is. So it just drops a message on the event bus, that's it. It doesn't care where it is. It just needs to drop the message and drop the data. So again, the data is the most important part. Vert.x systems will, and on the demo you will see that we are just exchanging data. We don't care about the API. We don't know where the service is. Just exchange the data, modify the data, pass it along again. A very quick look at the Vert.x topology. So you have the Vert.x instances, and Vert.x instance is the instance of the JVM. You can have one or more vertical instances inside it. Each is single-threaded and communicate over event bus. Can be clustered across all the Vert.x instances. The good thing is that you can distribute your Vert.x instances across your network anywhere. They can be anywhere on the network. They can connect to the same clustered event bus. They can connect to different clustered event buses. So you can have lots of flexibility how you can design this. And again, we're going back to the knowledge. Knowledge is everything. That's the name of the open source project for business systems automation that includes Drools, jBPM, Optaplanner, Uberfire, Dash Builder. Drools, most likely you have heard about that, a rule engine, including both the rule engine and complex event processing. jBPM for business process management and business process engine. Optaplanner for resource planning. Uberfire is a web framework for building consoles in a workbench style, inspired by Eclipse Workbench. And Dash Builder for data analytics reporting, producing dashboards with the charts and visualization of data and analytics. So as we discussed that we have the collected knowledge, we have the data defined, we have the rules, we have the processes, but usually when we start talking about that with business people, they will be defined in a natural language, like described, for example, we have a bank loan system, so we start defining rules for it. So if the loan is of a certain amount, then it's auto-approved. For example, below 1,000. If it's more than 1,000, then it requires a basic approval. So one person in the bank needs to look through it, check the applicant history, and if so, approve it. This is the definition of our knowledge on the very business level. Then we have to unify it and make it more of an executable model, or at least to have it as a model. So here we can use Drools and jBPM to actually capture the logic, capture the knowledge, and define that in a unified format. So we have the Drools language for our business rules. We have BPMN2 for our business processes. By that, we can make our knowledge, transfer our knowledge into so-called business assets. Business assets are data objects. Business processes, business rules, and so on. Then it will become a so-called knowledge archive. And since Drools and jBPM are Java projects, they will become a jar files. Actually, a kjar, so to say, knowledge archive. The single difference for it is that they have a simple XML descriptor defining that it is a knowledge archive. The knowledge archives are actually under control of Maven. So you can use the Maven dependencies, dependency management, centralized repositories, distribution of it, and so on. So all this stuff are available for this knowledge archive. So you can already take that advantage and well-known architecture of Maven and start using it in your services. So once we define our business archives or knowledge archives, we start building our services. And single microservice, knowledge-driven microservice will actually be backed with a single kjar. So you partition your logic, your business knowledge into kjars. Then you can start individual instances of your services that will be backed with a certain kjar. So you will see in a minute that we will have like a business rules archive that will actually contain all our business rules for qualifying the bank loan. Then we have another business archive or knowledge archive that will contain the processes for different types of loans. So we have a basic loan that requires a single person approval, and we have a long-term loan that will require manager approval and might require additional special terms to be set up. So a very simplistic view at the bank loan system: to apply, to qualify, and to approve it. Like three major steps in the bank loan system that can take. And of course, in reality, that will be way more complex. But just for the sake of the demo and be able to actually show it, I completely simplify that. So first step is that the applicant places a loan request. By loan request, we will see a certain information that the person needs to provide. So it provides just the data and just drops the request somewhere. Then we have a bank system that is actually taking the loan request, evaluating that, and qualifying. Is it maybe it's so low risk loan that it can be auto-approved. We don't have to involve anyone else. So the bank system can take the decision itself. But maybe it's a higher risk loan or long-term loan, so we need to qualify it, and we need to start certain steps that need to take in the bank itself to make sure that the bank representative approves or rejects the loan. So there will be different steps included. Then if we start moving that into services, then we can divide that as those three steps into three services. One is the apply for loan service, which usually will be like a UI system that allows user to put or enter the data that bank requires, most likely validate it and pass it along. Then we have the evaluate loan service, and last but not least is the process loan service. So this is where different steps might take place. So if we go into a bit of the details of the services, so yeah, main entry point. whoever would like to get the loan, go to that system, enters the data, giving the applicant name, monthly income, loan amount, and the duration, for how long you can take the money. So this is, again, the what. We just define the application, loan application, nothing else. So attempting to get a bit of information from the applicant to be able to process those. Evaluate. So this is the business rules. This is where we actually define what can happen, and if certain criteria are met, something else will happen. So if we provide the data that there is a very low risk loan, like below 2,000, then we can directly auto-approve it. We don't have to involve anyone. If we have something that is the amount for the loan is more than 1,000 and it's less than 5 years for the duration of the loan, we need to include a default bank representative that we just check the background of a given applicant to make sure that it's not a risk client or something. And then if we have a long term, which is more than 1,000 and more than 5 years, then we need to have a special staff to include as well. And this is why our rules, and we qualify the loan. And then we have depending on the classification of our loan, we can make a decision on what process or what steps needs to be taken to actually drive the loan till the end. So then we have the basic loan department that is just a bunch of guys that's sitting there and evaluating the loan request for the basic operations, so low risk, low amount and low duration of the loans. Then we have the long-term loans department that are different set of people that will have different set of steps to carry on with the approval or rejection. So now if you start putting those services into your environment, you start having like a free individual services that do not have anything in common. They are not dependent on each other. The only thing that they have in common is the data that they work on. The loan application, that's the only thing that they actually have in common. So they just drop stuff, pick up stuff from the event bus, nothing else. So if you start looking at how it actually works, so each service is self-contained. Everything that service needs to operate has inside it. It does not care if something else is available. It does not care if that API is of that version or of that version. It's completely self-contained. As I said, knowledge-driven services are backed by the kjar. So to be able to start a knowledge-driven service, you need to have something that actually brings in the knowledge to you. And again, services talk to each other by exchanging data. And thanks to the Vert.x event bus, this is a very simple way of exchanging data. The only addressing schema in Vert.x event bus is just the name. It's a simple string that defines where you're actually sending data. There is no API. There is no advanced interfaces that we actually need to understand to be able to exchange and communicate. You just drop the data. That's your interface. Services can be added dynamically or removed dynamically. So you can start as many service instances as you like, and you can shut them down and start them up anytime. They are not interfering. You can start a single service with specifying how many instances inside should run it, but at the same time, you can start multiple JVMs that will host different instances of the same service. And they can be anywhere in the network. All right, so let's go to a demo. So before, let me just... All right, so this is the key platform, the Knowledge is Everything platform that allows us to capture in a unified way our knowledge. So this is a web UI, so you can just go into project authoring. And here we have our, let me just open this. This is our long-term loan process, a very simple one. It computes the monthly rate. It asks for the manager approval, and if manager approved it, It might go either to the accepted notification, so we inform the customer, the applicant, yes, you got the loan. If it's not yet approved and it requires some special terms to be set up, there is another task that will be assigned to another individual or another group in your department that might be able to handle that and decide what to do. A basic one is even simpler. We have the clerk verification. If that person approves, it's send notification to the customer. If not, pretty much the same, but not really a happy message. And if we look at the rules, I can just hide this. There are just 3 rules that actually decide: is it auto-approved, is it a basic loan, or is it long-term loan? Just by evaluating the data that we send. We just grab the element that we got from the event bus, we check it, we can set, as you can see, I don't know if you can see it. Let me see if I can. Is it better now? Yeah, so we can set a certain attribute on the loan application that will be then, when sent over, this information will be already sent to the other parties that will actually work with that. So we just mark it as it's not approved, and we say with a small typo in it, it should be explanation, that it requires basic approval process. So we carry already information about what the rules that the Y has evaluated to. And then the most important thing is our loan application. This is a Java class that has a certain attributes. So we have 3 pieces that brings in our knowledge into the runtime environment. We have our data that is represented as a Java class. We have our business rules that are represented as a Drools language. And then we have our business processes represented as BPM N2 processes. All right, then let's see how that works. So we have 3 services. I will try to zoom in, zoom out to be able to show more. But so we can, in the first, let me use the technology here. Here, we have our Vert.x module that relies on the loan rules configuration, which actually just brings in the information about our kjar. And this kjar actually will be built from within the key workbench that brings in all the business rules. The business rules are here. So here we have our evaluate loan service. Second one is the loan process, which is built based on the kjar with our 2 business processes, basic loan and long-term loan. Last but not least is our client. And here we will see different, we will see polyglot support for it. So we start with a simple Java client. And as you can see, what's nice, if you can see it, it's a Java. So you don't have to compile. It runs the source. Vert.x will do whatever is needed to actually run your Java, but you specify not the class itself, but the source. I will just put that stick. So let's start our services then. So we're starting in clustered mode, so the services will talk to each other. It's deploying, as you can see, hopefully I can make it bigger. Can you read now? At least to some extent. So, we deployed a container with this group artifact inversion. This is a Maven structure. So we deployed the bank loan rules as a kjar, as a back end for our service. The rules vertical started, and so it's ready to run. That's fun. All right, then we do the same for our process. Again, bank loan process. This is the kjar. We started the jBPM vertical. So now it's up and running. So now we have our, where is this? Here. Our client. The client, I will show you the source of it. It is a single shot client. So it just generates a loan application based on random data. So it will generate random amount, random monthly income, and random username that is actually requesting the loan, and random duration of the loan. So that way we can see different rules being evaluated, different processes being started. So we're starting this. Started, and as you can see in the Drools part, we created a loan application for John with Java single loan request as a request ID, income 2000, requires basic loan approval process. So then the rules evaluated that the given loan requires a basic loan approval process. That means that there should be a process started for it. We don't have anything printed out here because since it's basic, it doesn't make sense to print anything. But you can go here. See if we have any process instances. Have the tasks. And we have the basic, can you see it? Can you read that? Have collect verification for basic verification for loan requested by John. So that already came into the business process management platform and started a task for Claire. That person can then go and evaluate the details. So we have the applicant name John, loan amount 7,000, monthly income 2,000, duration 2 years. And we can either approve it or reject it. Okay, as simple as just, can I do that? So I claim, so now it's assigned to me. So now I can make a decision if I approve it or not. And it's done. Then, let me see. So this is one shot. That's just a simple thing. So now let's try to use another one. That sends a new request, loan request, every 2 seconds. Again, it's generated. So you can see how much stuff you have. Every 2 seconds, something new is coming. New requests coming into. Same will be here. As you can see, different names, different types of basic verification for loan, manager approval. So it runs constantly. Every 2 seconds, we create a new business process. It just constantly runs. So here, we're calculating monthly rate. This is for the long term. And here you can see, you can't, that we have auto-approved as well, because it's below 1,000 or 1,000. So it's auto-approved. No process is started. Rule system decided, yes, this is low-risk loan. Let's approve it immediately. There is no need to do it. And you can see that the request ID is different because it's a different client. different client generating. So the client is actually, when sending the request, can again listen to responses. And as soon as the loan was auto-approved, it gets this notification immediately that for that given person, that given loan has been accepted or auto-approved. Then we can stop this. And then, if you are a Groovy fan, you can do the same with Groovy language. It will do exactly the same. But the thing here is that we want to scale it. So we just append instances and how many instances we want it to run. Because by default, it starts with a single instance. So there will be just one guy sending every 2 seconds a loan application. But if we started with 3 instances, it should now send 3 loan requests every 2 seconds. And you can see that, it's popping up with more instances. And exactly the same way, you can scale any of your microservices here. If you need more processing power on the rule service, just start it with dash instances and the number of instances you like there. For this demo, it's very simple. It's very quick. There is no time-consuming activities, neither for rules nor for processes. But to some extent, if you have like a long-running operation within the process, and long-running, I mean like even 2 or 3 seconds, then it's better to increase the number of instances that actually can process your request. Otherwise, the messages will be queued. Your system is not efficient enough, not fast enough. And now you can actually scale it the way you like and scale it individually. You can scale only the process service, or you can scale only the evaluate loan service, or you can scale the clients as we did. It's completely up to you, and you can just scale it by starting with dash instances or starting another instance somewhere else in the network on another machine that will process the messages the same way. Vert.x provides us with 2 options for sending data. It's send, which is point-to-point, or publish. The send is a nice thing because even though you have multiple instances listening for the same type of data, same components, the Vert.x will make sure they are distributed in a round-robin fashion and delivered to only one endpoint. Publish, and that's publish and subscribe. So sending one will be delivered to everything. And then with that, you can again have different operations and different types of stuff you can actually include in your microservice and expand them individually. Let me can stop this. As you can see, lots of stuff, and the request ID is actually here. Groovy loan request. And for different users, different amounts, it is completely generated. I can stop. And the same stuff we have for, if you like, JavaScript. Wait for something to get auto-approved. And of course, if you start doing here, go into tasks. We have almost 240 tasks already available. It's constantly creating the requests, and they're being picked up. So you can have this as a UI. You can have another microservice that will actually provide you with the visualization of your data, of your process, and collect the information again. Because here, when you click at that, it just shows you the form of the input of the loan application. You can build up another microservice that actually will communicate. So we'll get the information, we'll process that, approve it, reject it, whatever, send it over. Yeah. And here we have the JS loan request. So every single client has a different, and this is how it looks like it. A very simple code. Where's my magic stick? So we have the handler that is going to listen for the responses. So as soon as we get the response, it will just print it out. And then we have the send periodic. Every 2 seconds, we run this function. So it's just sending the message that it generates the JSON object. To simplify, to make it polyglot, we use JSON because it's the easiest format to consume in almost any language now, especially those that are supported by Vert.x. So we just fill in the data and send it to loan application. And this is just the name. It could be anything. Then the rules are listening to that and waiting for that information. And then just replying after evaluation. And then you can have this exact same code in Java, a bit more verbose, but still. That's the exact same thing. And Groovy, without syntax highlighting. So and that's pretty much it, I believe. We had the demo. Yeah, and again, you can just scale it by adding instances, and you can scale by adding 3 here, 2 there, 1 there, up to you to define, and based on the requirements. So, to sum up, main takeaways from the presentation is knowledge is everything, and really it is everything. Once you know what you're going to work with, you know your domain, you can make a wise and fact-based decisions. So think and keep in mind about the what, why, and how. Once you have that, you will be producing way better software for your actual end users. And yeah, those tools that you've seen here, Vert.x, Drools, jBPM, Hazelcast, are just the tools. Today you can use these tools, tomorrow you can switch them. But the knowledge, once you have that, the tools are just a secondary thing. They will be anyway replaced. That's the technology. That's happening every single time. And with that, I'd like to thank you very much for your attention. And if you have any questions, then